Hi guys, today we're going to do module 3, lesson 3, and we are going to work on solving problems solving multi-step problems using area and perimeter. So we're going to walk through 3 different problems that we are going to work on figuring out together. So the first problem says, we're going to read it through twice, the first time so we can get the gist of what it's asking, and then the second time so we can pick out the key information. So the problem says the rectangular projection screen in the school auditorium is 5 times as long and 5 times as wide as the regular screen in the library, or as the rectangular screen in the library, I'm sorry. The screen in the library is 4 feet long with a perimeter of 14 feet. What is the perimeter of the screen in the auditorium? So this question is extremely complex, and it's going to take a lot of steps to really understand what it's talking about. So what we need to do is we need to think really hard, and we need to make sure we draw a picture and remember our area and perimeter formulas, because those will help us. So let's read through again and highlight our key information. I'm going to, I think that's a highlighter. The rectangular projection screen in the school auditorium is 5 times as long and 5 times as wide as the rectangular screen in the library. Okay, the screen in the library is 4 feet long with a perimeter of 14 feet. What is the perimeter of the screen in the auditorium? I'm going to underline that sentence. Okay, so the first thing we need to figure out is what the width of the screen in the library is. So let's draw, because we know we can draw a picture. Draw a picture, pause the video, and draw a picture of what you think the screen in the library is going to look like. Okay, so the screen in the library, we know, is 4 feet long. And we know the perimeter, so we know the length all the way around the screen, right? So I know if this side is 4 feet, then the opposite side is also 4 feet. So we need to figure out what this side is and what this side is. Now, think back and recall what our equation for perimeter is. So we had 3 different equations. We had perimeter is equal to length plus width plus length plus width. So the perimeter is equal to all 4 sides added together. The perimeter is also equal to 2 times the length plus, that's an L, plus 2 times the width. And I'm going to put these in parentheses because the parentheses mean we have to do whatever's inside of the parentheses first. Okay. And then finally, we had this last question, or this last formula, where we could add the width plus the length, and we got half of our perimeter, so we knew we could multiply that by 2 to get the other half of our perimeter. So we can do 2 times the length plus the width. Okay, so I think the easiest one for us to work with is probably going to be our first question, or our first equation for us. So let's try with our first equation. We know the perimeter is 14 feet because it tells us that in the problem. Perimeter is 14 feet. So 14 feet is equal to 4 plus W plus 4 plus W. Well, I can put my two 4s together to make 8. So that gives me 14 feet is equal to 8 plus W plus W. Okay, so if I take my 8 and subtract it from 14, that gives us 6 feet. So the reason why I took my 8 away from 14 is because I knew I had a total perimeter of 14, and I know 2 of my sides are equal to 8. So I can take that away because we already know that piece of the perimeter. So then I have 2 sides left, which are both our W's, right? The width. And both of them are the same. So I need to think about what 2 numbers can I add together to get 6. 2 of the same numbers can I add together to get 6? And that will be what our width is equal to. So our width here is going to be equal to 3 feet. And we're going to go back and check just to make sure. So if I put, let me change my color. If I put a 3 in here and a 3 in here, I should be able to add 4 plus 3 plus 4 plus 3 and get 14. Okay, so 4 plus 3 is 7, and 4 plus 3 is 7 again, and 7 plus 7 is equal to 14. Okay, and we can't forget our unit, so we're going to make sure when we answer, we use feet. Okay, so I'm going to erase some so that we can do the second part of our problem. So we know that our width is 3 feet. We know that our length is 4 feet because we figured it out and we checked our work. Okay, so now we have to figure out what the perimeter of the screen in the auditorium is. So the screen in the auditorium, it says, is 5 times as long. So the rectangular projection screen in the auditorium is 5 times as long and 5 times as wide as the rectangular screen in the library. So we need to draw a picture of this crazy giant rectangular screen. And we know that it's 5 times as big. So 5 times really just means times 5, right? So 4 times 5 is how long it's going to be, and 3 times 5 is how wide it's going to be. So 4 feet times 5 is 20 feet, and 3 feet times 5 is 15 feet. Okay, so now we have our new dimensions. 20 feet is our new length and 15 feet is our new width. And you guys know how to find the perimeter. So go ahead and on your own, find your perimeter of the screen in the auditorium, and then unpause your video to check and make sure that your answer is correct. I'm also going to add our statement, because when we solve a problem, we always want to write our answer as a statement. Okay, so our statement is going to be the auditorium screen is the auditorium screen is 70 feet around. Or we could say the perimeter of the auditorium screen is 70 feet. Okay, let's do the next question. So remember, we're going to read this question twice. First time to get the gist of it, and the second time to pick out the key information. Okay, so it says the width of David's rectangular tent is 5 feet. And the length is twice the width. David's rectangular mattress measures 3 feet by 6 feet. If David puts the air mattress in the tent, how many square feet of floor space will be available for the rest of his things? So, in order to help us, we're going to draw a picture. We need to find we're looking for square feet, which means we're looking for area. Okay, so square feet. Let's underline that. Square feet. Ooh, no. Means area. Okay. And we're finding the area of two different things, right? We're finding the area of the tent, and we're finding the area of the mattress to help us figure out how much floor space is going to be available. Okay, so let's draw a picture, help us out. First, we need to identify the key components in order to draw our picture. So it says, it gives us the width of his tent, and it's a rectangular tent, which is 5 feet. And then the length is twice the width. So that means 2 times. So we're going to multiply by 2. David's rectangular mattress measures 3 feet by 6 feet. So that gives us a good dimension for his mattress. So we know the length and the width. Okay, so let's draw a picture. Here's my picture of my tent. Okay, we know the width is 5 feet, and we know the length is 2 times 5 feet, which that would be 10 feet. Okay, so 5 feet by 10 feet. And then inside, he needs his mattress is 3 feet by 6 feet. So let's see. 3 feet is going to be the shorter side, because it doesn't make sense that this part right here would be 6 feet, because 6 feet is greater than 5 feet, and that doesn't make any sense, right? So that side's going to be 3 feet, and this side is going to be 6 feet. Okay, so it would be important for us to find the area of the total tent. And then it would be important for us to find the area of the mattress. And then we can subtract those two to find the area of the inside part. That's what we're looking for, this yellow part. Our answer is going to be the area of the yellow part of the tent. Okay, so the area of the total tent, we know our equation for area is area equals length times width. Okay, so of the tent, T-E-N-T, our area is going to be 10 times 5. Okay, 10 feet times 5 feet. Okay, so figure out what that is going to be. And then the area of the mattress is going to be 6 feet times 3 feet. Okay, so the mattress is 18 square feet. Oh, I messed up. Let's go back. When we do area, we have to always remember we're measuring a surface, so our units are square feet. Square feet. So let me fix this too. Square feet. Okay, and then our total area of the tent is 50 square feet. Okay, so if I know the total and I know one part, how can I find the other part? So we know the total is 50 square feet, right? And then we know the mattress is 18 square feet. So think about our tape diagrams. Go back to our tape diagrams. Where our long piece of tape is our total area, which is 50 feet. Okay, and then this piece would be 18. Oh, these need to be square feet. I'm just going to draw feet squared. That's another way you can write square feet. Okay, and so we need to find this variable because that's going to give us our yellow part, the extra space for his stuff. So we can subtract and get 32 square feet for the area of his extra stuff. So let's write a statement describing our answer. The area David can set up his stuff is 32 square feet. Okay. Okay, let's do one last question. Okay, this says Jackson's rectangular bedroom has an area of 90 square feet. The area of his bedroom is 9 times that of his, ooh, this sentence got messed up. Pause. Okay, back to our problem now that I have fixed it. Jackson's closet or rectangular bedroom has an area of 90 square feet. So it's giving us the area. The area of his bedroom is 9 times that of his rectangular closet. If the closet is 2 feet wide, what is its length? Oh my goodness. Okay, so we first need to draw a picture. So I'm going to draw a picture of Jackson's bedroom. Okay, and we know the area is 90 square feet. Okay, that's all we know. We don't know the length or the width of his bedroom. We do know some stuff about his closet. So his closet, his bedroom is 9 times as much as his closet. So if I was to take this picture and split it into 9 pieces, if they were even, this would be much more accurate. But if you think about it, 90 square feet, what can I divide 90 by to figure out how much square feet is going to be in each of these boxes? Well, I know there's 9 boxes because it's 9 times that. So really we're thinking about 90 is equal to 9 times something, right? And we know our 10s facts, right? And our 9s facts. So we know that 9 times 10 is going to equal 90. So each of these boxes is 10 square feet. And if we add 10 together 9 times, that's going to give us 90. Okay, so his closet is 10 square feet. That's the area of his closet. Okay, so we know, we're also told that the closet is 2 feet wide. What is its length? So 2 feet. Okay, so if the closet's 2 feet wide, we need to figure out what 10 is our area. Okay, we need to find the length because we're given the width, which is 2 feet. Okay, so what times 2 is going to give us 10? 2, 4, 6, 8, 10. 5 times 2 is going to give us 10. So the length of this closet is 5 feet. Okay, so we've answered the question. The question was just, what is the length of the closet? This question was a lot easier than I thought it was going to be. Very nice. Excellent job. Excellent job. Good work, team. Okay, so now you need to go practice on your own. Make sure you read through the question twice. Okay, get a gist of it the first time. Really pick out the key points the second time. Make sure you draw a picture to help you, and work as far as you possibly can until you get stuck and don't know what to do anymore, because these questions are challenging. Good luck.